Hey guys, Miss Toledo here. We are going to continue exploring equivalent expressions this week and start to look at the distributive property. And many of you guys may remember the distributive property from math last year. But of course, the trend of math 7 is that this year we're going to start to involve some negative numbers in there. So let's just review a little bit about the distributive property before we get started. So first of all, we can use that distributive property to simplify expressions. And as we know from our work with combining like terms last week, we know that when we simplify expressions, we're really writing equivalent expressions. So let's take a look at how this distributive property thing works. So first of all, if we're being asked to simplify the expression 3 times the quantity or the sum of x plus 5, this really means the same thing as 3 groups of x plus 5. And we know that when we have multiplication, it's really the same as repeated addition. So in this case, we are multiplying 3 times the quantity of x plus 5. So we have x plus 5 3 times. So what does this look like? We have x plus 5 one time, x plus 5 another time, and x plus 5 again. And because this is repeated addition, we're going to add all of these x plus 5s together. When we look at this expression, we know it's definitely not in its simplest form, so we can go ahead and use what we know about combining like terms to simplify. So we can identify those like terms. So we have our x's, and we've got our constants that we can combine. And really we have x, so we have 3 times x, we have x 3 times, and we have 1, 2, 3, 5, so we have 5 times 3, or 3 times 5. So our simplified expression, 3 times x is 3x, and 3 times 5 is 15. And we know we're combining it all together. So our simplified expression is really 3x plus 15. So while this got us to our simplified expression, this is probably not the most efficient way for us to simplify this kind of expression. So the distributive property is what allows us to multiply each addend, or the number that we're adding, separately, and then add or combine their products. And of course, product is the answer to a multiplication problem. So what this really means is that we can multiply each of these addends. We can multiply x and we can multiply 5 by 3 separately, and then add their products, or what we get together. So we did 3 times x, 3 times that x, and got 3x. And we did 3 times 5 and got 15, and then we added those products together to get our simplified expression. And we verified using that idea of combining like terms that that does in fact work. So let's look at a couple different ways that we can approach simplifying expressions with distributive property. So one of my favorite ways is using the area model. And while you might not love this or need it for distributive property, it's definitely going to come in handy when we get to factoring later on. So we're going to use the area model to write each area of each of these rectangles as a product of length times width and as a sum of the 2 different areas. So we look at our first rectangle, we have a bigger rectangle and then 2 smaller rectangles within that. So if we want to write the area as a product, meaning the result of multiplication, we know to find the area of a rectangle, we multiply base times height. So in this case, we know 5 is the height of our rectangle, and our base is whatever x is plus 7. So here's our base, x plus 7, whatever that is, the sum of x plus 7. So to write this as a product, we're going to take our base or our height and multiply it by our base, which is the sum of x plus 7. If we want to write this area as a sum, meaning we would know the areas of each of these 2 rectangles and add them together, we can do that also. So we know, again, to find the area of a rectangle, we multiply the height by the base. So if we look at this first rectangle, the height is 5 and the base is x. And 5 times x would give us the area of 5x. And we can do the same thing for our second rectangle. So again, we know the height is 5 and the base is 7. So to find the area, 5 times 7 would be 35. If we want to find the area again of that whole rectangle, we would take the area of the smaller rectangle and add it to the area of the bigger rectangle. When we think about how this relates to what we did above, really what we did was we took 5 and multiplied it by part of the base and got our area of this rectangle, and took 5 and multiplied it by the other part of the base to get this area, and then added those together. And we certainly ended up with our simplified expression. So let's take a look at another example. So again, we have our rectangle here. Our height is -2. Our base of the first rectangle is 3m and the second is 4. If we want to know the base of the whole rectangle, we just have to take these two bases and add them together. And whatever their sum is will be our base of the whole rectangle. So to write this area as a product, we take our height of -2 and multiply it by the sum of 3m plus 4. If we now want to write the area as a sum, which would be our simplified expression, we can take the height of our rectangle and multiply it by the base of the first rectangle. So -2 times 3m would give us the area of the first rectangle, which is -6m. And to find the area of our second rectangle, we would take our height of -2 and multiply it by our base of 4, which would give us -8. If we want to combine these two areas, we have -6m plus -8. Or we can say, since we know adding -8 is the same as subtracting +8, we can simply rewrite it like this. So this area model may come in handy for you, and if you're still having trouble, by all means continue to use it. But we're also going to talk about some more simplified procedures for using that distributive property. So in general, when you distribute something, you give that thing to every person in the group. So it wouldn't be very nice of us if we had a present and we just gave it to one person in the group. So to be fair, we're going to give that present to everybody in that group. And once we give a present to everybody in the group, we have a person with a present and then another person with a present. Math is not much different. To distribute in math, we simply multiply each term that's inside the parentheses by the term outside the parentheses. So let's take a look at what this looks like. So our first example, we have 3 times the quantity of x plus 5. So we take our term outside the parentheses and we multiply it by each term inside the parentheses. So we take 3 and multiply it by x, and we get 3x. And then we would take 3 and multiply it by 5, which gives us +15, so we would add 15. And now we have a simplified expression. We've eliminated our parentheses. I think it's pretty helpful to draw those arrows to make sure, again, that we're giving this term to everything inside the parentheses. We're being fair. So it helps me to make sure we're doing that. Let's take a look at another example. We have -2 times the quantity of 4m plus 1. So again, we're going to take our term outside the parentheses and we're going to multiply it by everything inside the parentheses. So -2 times 4m is -8m, and -2 plus 1, or -2 times +1 would be -2. So I would subtract 2. And again, now I have a simplified expression because I've eliminated all of my parentheses and there are no like terms for me to combine. Let's take a look at one more example. We have 1/3 times the quantity of 6x minus 12. So we're going to take 1/3 and multiply it by everything inside the parentheses. And 1/3 times 6x, or 1/3 of 6x, is 2x. And 1/3 times -12 would be -4. And since it's negative, we're going to subtract 4. And again, now that I have eliminated my parentheses and there are no like terms, I have successfully simplified my expression. There are some situations where simply using distributive property will not simplify our expression fully. So we want to make sure that to simplify it fully, we're using both distributive property and combining like terms. So as we mentioned earlier, we use that distributive property to simplify expressions, but in order to fully simplify, we should also combine any like terms if it is possible. So we must still follow those order of operations, that PEMDAS rule. So any combining of like terms, which would be considered addition or subtraction, should happen after we distribute, because distribution is multiplication. So distribution is our multiplication, where combining like terms is really addition and subtraction. So we still need to make sure we follow those order of operations and do multiplication first and then any addition or subtraction. So let's take a look at what this looks like in action. So example number 1, we have 5 times the quantity of negative 4a minus 4 and then minus 2a. So first of all, we're going to start with eliminating our parentheses because we need to follow those order of operations. And we know multiplication, which happens when we see that number next to the parentheses, has to happen before we add or subtract anything. When we distribute our 5, this number outside the parentheses, or what's being multiplied by the items in the parentheses, we're only going to distribute to the items inside of the parentheses. So 5 times negative 4a would be negative 20a, and 5 times negative 4 would be negative 20, so we're going to subtract 20. And we can't forget about this negative 2a, so we're just going to bring that on down. Now when we take a look at this expression, we can see there are still like terms here, which means that our expression is not fully simplified. So I'm going to go ahead and circle my like terms, and I'm going to combine those. So negative 20a minus 2a would be negative 22a. And then we're going to bring down that minus 20. And now I have an expression where all of my parentheses have been eliminated and I have no more like terms. Let's take a look at one more example, and this one's a little bit tricky. So we have 10 minus 2 times the quantity of 3m minus 2. Again, if we think about order of operations, multiplication has to happen before addition or subtraction. Many of you also are saying, hey, Ms. DeLuto, what about the parentheses? So if we look inside our parentheses, 3m minus 2, we can't really do anything to simplify inside of our parentheses. So we would move on to our next step, which would be that multiplication, which we see right here. Now we need to make sure that before we do anything with this 10, because we can't subtract before we multiply, that we're going to do our multiplication, and we have to pay attention to the term that we're multiplying by. And that's going to be that 10 minus 2. We have this negative 2. If you're not sure why, I'm going to rewrite this expression to show you. So we know subtracting positive 2 is the same as adding negative 2. So when we look at this expression in this regard, we know that negative 2 is what's being multiplied by those terms in the parentheses. So let's start with that. We can bring 10 down because we're not going to do anything with that just yet. And we have negative 2 times 3m, which is negative 6m, so we're going to subtract 6m. And then negative 2 times negative 2, which is positive 4, so we're going to add 4. And again, looking here, we still have like terms, so we're going to circle our like terms and combine those. So 10 plus 4 is 14, and then we're going to continue with that negative 6m. And now that I've eliminated all of my parentheses and I don't have any more like terms, we have officially and fully simplified our expression. So as you guys work through your practice problems this week, make sure you're paying careful attention to your signs. Make sure you're paying attention to if your expression has been fully simplified or not. And of course, make sure you are distributing to everything inside the parentheses. Draw those arrows to help you. Good luck, guys. Can't wait to see you at our check-ins. Have a great week.